When dealing with power cables in a raised floor environment for offices, it's generally recommended to use THHN, which stands for Thermoplastic High Heat Resistant Nylon Coated, or XHHW, which stands for Cross-Linked Polyethylene High Heat Resistant Water Resistant Stranded Copper Conductors. These should have polyvinyl chloride, or PVC, insulation and a jacket. It's important to select voltage and ampacity ratings that are appropriate for the electrical load that the cables will be carrying. For communication cables, specifically for data transmission, Cat6 or higher twisted pair copper cables are recommended. For voice communication, Cat6 or higher cables should be sufficient. Flex cables, also known as flexible conduit, do require support when used in this type of installation. Common methods for providing this support include the use of cable trays, J-hooks, or spring clips. The recommended spacing for supporting flexible conduit is at intervals of 5 to 6 feet. As for whether liquid-tight cabling is necessary, it's typically not a requirement in raised floor applications unless there is a specific risk of exposure to water or other liquids. There are additional considerations to keep in mind. Firstly, it's important to select cables that are rated for the required fire resistance level of the building in which they are being installed. Secondly, if the cables will be installed in a plenum area, which is an air handling space, then plenum-rated cables must be used. Thirdly, it's critical to secure the cables at connections using strain relief devices. This will prevent damage from movement or tension on the cables. Fourthly, ensure proper grounding of all cables and equipment for safety purposes. Finally, implement proper cable management practices. This can be achieved using cable ties or Velcro straps to organize and manage the cables. This helps prevent clutter and tangles, making maintenance and troubleshooting easier in the future. When selecting THHN or XHHW conductors, ensure the ampacity meets the load requirements as per the National Electrical Code, NEC, Table 310.15b16. This table provides allowable ampacities for insulated conductors rated up to and including 2000 volts, based on insulation type and installation conditions. When selecting communication cables, consider future bandwidth needs. While Cat6 may suffice for current voice and some data applications, Cat6 offers superior performance and supports higher bandwidths, making it a more future-proof choice for data-intensive applications. The selection of J-hooks or spring clips depends on the specific installation environment and the type of flex cable being used. Ensure that the supports are adequately sized and rated to support the weight of the cables. Also, consider using cable trays for larger cable runs or when multiple cables need to be supported in a single location. In areas where liquid-tight cabling is not required, consider using flexible metal conduit (FMC) or electrical metallic tubing (EMT) as alternatives to reduce costs and improve flexibility. These options provide mechanical protection for the conductors while being easier to install and maintain in liquid-tight conduit. Fire-rated cables are designed to maintain circuit integrity during a fire, preventing the spread of flames and smoke. These cables are typically used in emergency circuits such as fire alarms, emergency lighting, and fire pumps. Plenum-rated cables are designed to minimize the release of smoke and toxic fumes in the event of a fire. These cables are required in plenum spaces to prevent the spread of harmful substances through the building's air handling system. Strain relief devices prevent stress on cable terminations, reducing the risk of damage and electrical faults. Use appropriate strain relief connectors and clamps at all cable entry points to ensure secure and reliable connections. Proper grounding is essential for electrical safety and to prevent equipment damage. Grounding ensures that fault currents are safely diverted to ground, reducing the risk of electrical shock and fire hazards. Follow NEC Article 250 for grounding requirements. Cable management is crucial for maintaining a clean, organized, and safe cabling system. Use cable ties, Velcro straps, and other cable management accessories to bundle and route cables neatly. Label cables at both ends to facilitate identification and troubleshooting. Maintain adequate separation between power and communication cables to minimize electromagnetic interference. Consider using shielded cables in areas with high levels of electrical noise. Ensure that all cables are installed in accordance with the manufacturer's recommendations and applicable codes and standards. Regularly inspect the cabling system for damage, wear and tear, and repair or replace any damaged components promptly. Document the cabling system, including cable types, routes, and termination points. This documentation will be invaluable for future maintenance and troubleshooting. When using cable trays, ensure they are properly grounded and bonded to the building's grounding system. This will help prevent the buildup of static electricity and reduce the risk of electrical shock. Use appropriate bushings and grommets at cable entry points to protect cables from abrasion and damage. Consider using color-coded cables to simplify cable identification and troubleshooting. Use a cable testing tool to verify the performance of communication cables after installation. This will ensure that the cables meet the required performance standards for data transmission. Regularly clean the raised floor area to prevent dust and debris from accumulating on the cables. This will help maintain proper ventilation and prevent overheating. Ensure that the raised floor panels are properly grounded and bonded to the building's grounding system. This will help prevent the buildup of static electricity and reduce the risk of electrical shock. Use appropriate floor grommets to seal cable openings in the raised floor panels. This will help prevent the escape of conditioned air and maintain proper airflow in the data center. Consider using a cable management software to track and manage the cabling system. This software can help automate cable documentation, track cable inventory, and simplify troubleshooting. Ensure that all cables are installed in a neat and orderly manner, without any kinks or sharp bends. This will help prevent damage to the cables and ensure optimal performance. When routing cables under the raised floor, avoid obstructing access to equipment or creating tripping hazards. Use cable ladders or other cable management structures to keep cables organized and out of the way. Consider using pre-terminated cables to simplify installation and reduce the risk of errors. Pre-terminated cables are factory tested and guaranteed to meet the required performance standards. Ensure that all cable terminations are properly labeled and documented. This will help facilitate future maintenance and troubleshooting. Use a cable labeling machine to create clear and durable cable labels. Regularly inspect cable terminations for corrosion, damage, or loose connections. Repair or replace any damaged or corroded terminations promptly. Consider using a cable management consultant to design and implement a comprehensive cabling system. A consultant can provide expert advice on cable selection, routing, and termination, and help ensure that the cabling system meets the specific needs of the data center. Ensure that all cables are installed in accordance with the applicable codes and standards, including the National Electrical Code, NEC, and the Telecommunications Industry Association TIA standards. Regularly review and update the cabling system documentation to reflect any changes or modifications. This will help ensure that the documentation remains accurate and up to date. Consider using a cable management system that integrates with the data center's building management system (BMS). This will allow for centralized monitoring and control of the cabling system. Ensure that all cables are properly supported and secured to prevent sagging or movement. This will help prevent damage to the cables and ensure optimal performance. When routing cables near heat sources, such as HVAC equipment or power supplies, use heat-resistant cables and provide adequate ventilation to prevent overheating. Consider using a cable management system that incorporates cable routing guides and pathways. This will help ensure that cables are routed in a neat and orderly manner and prevent tangling or crossing. Ensure that all cable connectors are properly seated and secured. Loose or improperly seated connectors can cause signal degradation and connectivity problems. When terminating cables, use the appropriate tools and techniques to ensure a secure and reliable connection. Poorly terminated cables can cause signal loss, interference, and other performance issues. Consider using a cable management system that includes cable trays, ladders, and other support structures. These structures can help organize and support cables and prevent them from sagging or becoming tangled. Ensure that all cable pathways are properly sized to accommodate the number and size of cables being routed. Overcrowded cable pathways can cause damage to the cables and restrict airflow. When routing cables through walls or floors, use appropriate fire-stop materials to prevent the spread of fire and smoke. Fire-stop materials are designed to seal cable openings and prevent flames and smoke from passing through. Consider using a cable management system that includes cable identification and labeling. This will help simplify cable tracing and troubleshooting and reduce the risk of errors. Ensure that all cable labels are clear, durable, and easy to read. Faded or damaged labels can make it difficult to identify cables and troubleshoot problems. When working with electrical cables, always follow proper safety precautions to prevent electrical shock. De-energize circuits before working on them, and use appropriate personal protective equipment (PPE), such as gloves and safety glasses. Consider using a cable management system that incorporates cable monitoring and alerting. This system can monitor cable performance and alert administrators to potential problems, such as signal loss or interference. Ensure that all cable monitoring and alerting systems are properly configured and maintained. False alarms can be disruptive and time-consuming. When routing cables in areas with high levels of electromagnetic interference (ME), use shielded cables and grounding techniques to minimize interference. EMI can disrupt data transmission and cause performance problems. Consider using a cable management system that includes cable documentation and reporting. This system can generate reports on cable inventory, usage, and performance. Ensure that all cable documentation and reporting systems are properly maintained and updated. Accurate and up-to-date documentation is essential for effective cable management. When working with fiber optic cables, always handle them with care to avoid damage. Fiber optic cables are fragile and can be easily damaged by bending, twisting, or pulling. Consider using a cable management system that includes cable testing and certification. This system can test and certify cables to ensure that they meet the required performance standards. Ensure that all cable testing and certification equipment is properly calibrated and maintained. Inaccurate testing results can lead to performance problems and reliability issues. When routing cables in the areas with high levels of humidity or moisture, use moisture-resistant cables and connectors. Moisture can damage cables and connectors and cause corrosion and electrical problems. Consider using a cable management system that includes cable access and security. This system can control access to cables and prevent unauthorized modifications or tampering. Ensure that all cable access and security systems are properly configured and maintained. Unauthorized access to cables can compromise data security and network performance.